focus on the action classification challenging task. And in the afternoon, we are going to start at 2:30. So it's a little different to the original workshop schedule. For the action, we are going to, in the afternoon, we are focus on the action detection. So the action classification. So the action task, classification task is that given the video, we try to assign label to the task videos. And this year we choose this problem as a multiple class classification problem. And the goal is we try to recognize a large number of action classes from the videos in the white. So this kind of videos is supposed to be very unconstrained with videos with various of background, viewpoint, and the camera motions, something like that. So this year, as we mentioned earlier, we use UCF101 actually as the benchmark. So this set has 101 action classes, and we constantly group them to 5 categories, which have like a human object and the actions. And also have the secure human body motions, like this walking with a dog, and playing instrument. This also can be a subset of the human object in the action, but we have a separate group for them. And then is the human-to-human interaction. For the actions have more than 2 persons involved. And the major action classes is from the single person sports actions. And in the evaluation, this set we have like over like 30,000 video clips, and in each class there are 25 groups with 4 to 7 video clips. In each group, actually the videos may share some like a similar background or the actors. And all the videos have the same frame rate of 25 and also video resolution of 220 to 40. And the total time duration for the dataset is 1,600 minutes. The mean length for the videos is 7.2 seconds, and the minimum one is 1.6 seconds. The maximum length is 71.4 seconds. So here is the distribution of the number of class on the each action class, and also we have the distribution for the different the number of videos for different runs, and we can say the majority of them is between which lasts 5 to 10 seconds. And here is some other set of the distributions. And one issue we look at most of the playing instrument that has longer videos. In this evaluation, we provide 3 low-level features, and for the steep and the safe, we provide both raw feature and a bag of histogram features. And for the DTF, we only provide the bag of histogram features, because the raw feature is too big to share online. And we have 3 training and testing splits, and in each split, we randomly select like 18 of the 25 groups for training, and the rest, which is like 7 of the 25 groups for used for testing. Each team can allow to submit multiple runs, and in each run, it must include results from all the splits. So officially, we report the average class accuracy, which is the mean of the main diagonal of the confusion matrix. So this year we got 30 runs from 70 teams. There are some of them dedicated for list, like the CS, and is China Normal University or India, France. So I'm not going to go through all of them because the next one I'm going to talk about the overview of the approaches. So the static AS team use the improved dense trajectory features. For the encoding, they use the graph and the visual vectors, and then use linear SVM. So the original performance is 84%, but they actually messed up the indexing, class indexing for 4 categories. So after they correct this indexing, they actually jumped to 87. And NU team actually did this working different. They only use the sparse shift and the steep. And they developed their own, they call it expanded relativity motion histogram. So the basic idea, they're trying to capture the relative motions between the visual worlds. And they assume this is going to capture the object and the same relative motions. And based on that, they are going to use the diffusion approach to smooth the histogram. So that's very interesting. And also for the activity use SVM and smooth distance. So here they directly apply the CRCV table on this data set using the improved dense trajectory features. They do the radius stabilization, but I think for this one they didn't do the pulsing detection. They also use the visual vector and with linear SVM. The Florence team explored all kinds of features like DTF, STIP, P-SIFT, which is pyramid SIFT, and the PO SIFT. And they also have all kinds of encoding approach like visual vector, backwards, or this ASC, plus the spatial pooling approach. So basically they have got like 11 channels, and then use the one regularized logistical regression approach to fuse all the performance, all the channels, and finally use the CRF to smooth the score. And the Nanjing team, they basically only use DTF, but they use based on the web encoding, they have their own like a bimodal encoding approach to normalize each bin. For classification, they use their own like a power mean SVM approach. The NI team, this is the only team they use audio feature, and they demonstrate the audio feature can improve a little bit. But we don't actually have audio feature for all the classes. We only have audio feature for 50 classes. The TNO only use the steep feature, and they say this feature can improve all the baseline lot. The UEC team, they developed their own spatial temporal feature based on the surf triangulation. And they already submit paper to the research check, so I think they are going to give a talk on this. The UNITM team explored all kinds of 3D features like 3D HOG, 3D HOF, and HOG color, and HOF color. The team, the camera, they use really focus on dense trajectory features. They have implemented this order trajectories. And they also have a paper on this research check. They are going to give a talk on this. So basically, instead of only have all the trajectories has like 50 frames, they also explore the longer trajectories. The US team use more SIFT, so that's the difference. The team from the Ottawa, they applied the recent work they call local part model, which published on CRCV 2013 to extract local features. So basically, they have a root and also 8 paths, and based on this kind of local part model, they getting new features. So and then use the SVM with histogram section as the classification approach. So the second group of approach I would like to highlight is that they use both the low-level feature also the middle-level feature. And the middle-level feature, I think, is they developed all the low-level feature and maybe have some semantic meaning or something like that. So, like say the first thing, like you say SD team, they developed this like actor, and they have a paper in this CRCV conference. And basically, they have two layers. And the first layer is the low-level feature, and the second layer is the actor. And the actor actually they randomly sample some like volumes and put a feature on this volume. Then use multiple distance learning to discover the actors for each action classes. And so they demonstrate that actors can get in similar results to the lower features, but not as good as the lower features. But the combination actually can improve a lot. So the next one is the team buffer. I think just give a talk on this. They use the action bank features and also plus some dense trajectory lower features. The team from UNAL, they basically use the deep dense trajectory features and using this online matrix factorization. So they claim this approach can project the lower features to the semantic space and then use the semantic feature to do the recognition. So they use the team from UCF, Marshall Taylor's group. They use the based on the lower features, the dense trajectory feature. They propose an approach to discover this discriminative sub-bridges, and then they are also combined with the back of words lower feature and the feature vectors. And but in the classification, they didn't use SVM. They used the two-layer neural network with job out approach. So they get a very good results. And then the last one is the team from UMD. I think this is the only team they didn't use directly use lower features. They actually is perform on the middle level features. They use the so-called label consistent KSVT, which is kind of sparse coding to discover the discriminative vocabulary and do the recognition of this semantic vocabulary. So overall, the observation is, I think most teams use the lower feature, most teams use the dense trajectory feature or the improve the dense trajectory, which give very good performance. And we also see some groups, teams also explore some new features, which also give very reasonable results. So for the middle level feature, I think so far it's not performed as good as the lower feature, but most of the approach is newly developed, and some teams actually demonstrate that the middle feature can perform very close to the lower feature. So for the coding of this pool, most teams use is backwards facial vector via red coding, and with spatial pooling and visual pooling. In the classification, either use the non-linear or linear SVM. And but this in this task we also see some new techniques like they improve the dense trajectory features and actors, and also the local part model. And we also have to get some issue to the research check. They explore new approaches. So here is the rank. I think I'll let you the results. And so as I mentioned, there is some method for the team from CS, and also that team from US Auto, they actually put this to the research check, so we didn't get a chance to evaluate their performance, but their performance is also good. So this plot, I want to show how diverse across all these three splits, and if we look at here, the split variation is very small over all these three splits, which means the split is meaningful. And here is the class variation over all the teams, and they have very similar variance. Another interesting statistic I want to show is the number of class won by each team. So that's we only look at the top one. So this is not exactly very similar to the previous one. And we can look at here is like say even that we use the original results and the CS team they actually achieve the most classes as the top, and then followed by this Florence and Nanjing. And then if we look at the top 5 class, and then the rank is kind of different. The CS is still the same, and then India again to the second one. So here this one is very consistent to the average accuracy. But I think we can look at this approach. There must be some like interesting insight over here between the different approaches, which the approach is very diverse. So the next one I'm going to show is the video level difficulty. This is also very interesting observation. So we define the difficulty value as the number of messages which appeared on this video divided by the total number of submitted messages. So the value for the difficulty is between 0 and 1, and 1 indicates the most difficult ones, which means like no approach actually recognizes the video. And here is the histogram, and the right side is very difficult. Has most difficult, and this one is easier. And then the y-axis is the total number of videos corresponding to the different difficulty scale. And we can see actually almost 65% of the videos are correctly classified by the majority of the submissions. So here is another view to look at this one. We actually get the video level difficulty over the class level, and we rank them. And the right side is all these classes. They are very difficult. And here is some. This is the 15 classes. They are very difficult, and we can see over here the hammering and the handstand. Walking or mopping floor, haircut. I think all these actions they have very diverse, like either background or different viewpoint, and also the content is very diverse. So that's why it's very difficult. And another one I want to share with you is I want to show some videos which never recognized by any team. So that here is the first row is the 4 videos. And I select from all the results, and this is never recognized by anything. So this is the moving floor, and the next one, this one is the one recognized by some teams. Basically, they are from the same group, I think from the same video, but they have different clip. But this one is recognized. So I think the difference is on the motion. And we also have this one, this rope climbing is never recognized by any approach. But this video is recognized by all the approach. So visually it's very difficult to say, but I think the resolution also makes a difference in the viewpoint.
So in this one, the person is very small.
Yeah, the scale maybe so far not many approach. Consider about the scale from the scale problem, because most of them use as local features. So that's the problem.
And the first example they are reverse.
Yeah, this is Iraq, and this has swing the. So the motion is, I think it also depends. So which also means the most approach is not very generalized. And so this one, we also can look at this one. This is shot put. And this shot is very professional. It's recognized by all the approach. This one is not professional, so motion is not very obvious, so it's very difficult. I think we can, looking at these results, it's good for us to debug our approaches and in the community, and also we can focus on the hard exams in the future. So for this one, actually the PISA, so they have also motion, but the motion is focused on the PISA, not focused on the human body. But look at most of them actually the entire human motion. So that's why that's very interesting. Yes. And the last one here, the last statistical information I want to share with you is that since in the beginning I mentioned we group these actions to 5 categories, and we show the results for the average accuracy for each of the groups using the based on the submission, all the submissions. And then we can see that actually human object interaction, the body motion only, and the human interactions is very is more challenging as compared to the playing music instruments and the sports. So in summary, so I think the lower features is was better than the middle features. The lower feature is like a facial vector and the speech template print. But I think the middle level is catch up, is getting like a close performance to the lower feature. And I think in the future, the evaluation, I think that we expect to have more submission to export the middle level feature. I think this is more useful for maybe for the like X short learning. And this year we also provide the class level attributes, but I think people haven't figured out how to use it. So hopefully next year people can catch up this one. And we also need more submissions to use a normal approach, using a normal approach. For future evaluation, if we want to make this task more challenging, I think we can focus on the X short learning, like 1 shot learning and 0 shot learning. That's any question?
How can we use other methods of
that can be, of course, can be one measurement, like also the mean average precision. But since our this task, as mentioned in the beginning, is multiple class classification, and in the academic areas, most people use the confusion table, which is only considered the accuracy of the diagonal of the confusion table. So that's we keep focus on this in this year. But in the future, if we keep increase this set of the number of classes, we may think about to use another one mean average precision.
Because in that sense, not always when you get the best accuracy, you also get the best.
You mean the precision because how to balance them? So that's the classification problem. But I think the mean average precision we actually have better measurement than the F score if we consider it's not a multiple classification problem. Okay, so
correctly introduce the notation of the attributes for use.
Yeah, that's good. I mean, the attributes is going to, I think in the afternoon we're going to start at 2:30, and Jingen is going to introduce the class level attributes. And we also welcome comments from all you guys on how to improve the attributes and how to do some like future evaluation on the attributes based action classification.